Hello guys, we'll talk about VLAN headers and VLAN encapsulation. Generally speaking, network elements that implement the IEEE 802.1q standard are said to be .1q compliant. Consequently, they are referred to as VLAN-aware. In contrast, network elements that neither support VLANs nor process VLAN tagged frames are said to be VLAN-unaware. VLAN-aware devices include managed Layer 2 and Layer 3 switches, routers, firewalls, wireless controllers, wireless access points, IP phones, and VLAN-aware processes that run on network and server operating systems or virtual machines. Generally, user devices such as personal computers and mobile phones are VLAN-unaware. Other VLAN-unaware devices include IP cameras, network printers, and network devices and terminals that do not support the .1q specification. A normal communication between a VLAN-aware node and a VLAN-unaware node involves exchanging data frames that do not contain any VLAN tags, meaning only untagged frames can be sent and received on this link. In situations where VLANs are misconfigured, a VLAN-aware node may send a .1q frame to a VLAN-unaware node. In this case, this tagged traffic may be forwarded transparently as normal or completely discarded. The latter case will result in subsequent communication failures. Between two VLAN-aware nodes, however, the situation is different. Tagged and untagged frames can be exchanged on the link with no communication failures, provided that all configurations are correctly performed. The difference between the .1q tagged frame and the untagged frame lies in the presence of a VLAN tag or VLAN header. This tag is inserted between the source MAC and the type fields of the standard Ethernet frame to form the .1q frame. The VLAN tag is a 4-byte field that enables VLAN-aware devices on a network to confine a frame within the VLAN on which it was received. In this illustration, PC A and PC B on switch A and switch B respectively are attached to VLAN 100, and PC C and PC D in a similar fashion are attached to VLAN 200. When PC A sends traffic destined for PC B, the frame is sent without a VLAN tag, as PC A cannot send VLAN tagged frames. Switch A will receive this frame, and after consulting its MAC table, it finds that PC B is on VLAN 100. It then adds a .1q tag before sending to switch B. This tagged frame contains a VLAN header with the following description. The first section is the tag protocol identifier, a 2-byte field which identifies the presence of a VLAN tag within the frame. The value it holds contains information about the tag format, which is most commonly a hexadecimal value of 8100. Other values which are outside the scope of this course are 88, A8 and 88E7. The next section is a 2-byte tag control information which carries parameters related to this VLAN tag format. It contains 3 fields, namely the PCP, DEI, and VLAN ID fields. PCP, or Priority Code Point, is a 3-bit field with priority values ranging from 0 to 7. It is used in traffic classification by providing differentiated services for traffic such as data, voice, and video. A higher priority value indicates a higher forwarding preference on the network. Formerly known as canonical format indicator, the drop eligibility indicator is a 1-bit field which holds a true or false drop eligible value that determines if a frame should be dropped in the event of a network congestion. This drop eligible value may also be encoded in the PCP field of the VLAN tag instead. The last field is the VLAN ID field. It is a 12-bit field that determines the actual VLAN on which a frame will be propagated. Its value ranges from 0 to 4095. On most implementations, however, VLAN IDs 0 and 4095 are reserved, leaving the configurable VLAN IDs as 1 to 4094 to forward service and management traffic. Most VLAN-aware bridges also use VLAN 1 as the default VLAN ID of its port. This port's VLAN ID of 1 can only be blocked but cannot be deleted or deactivated on the device. In most practical applications, only the tag protocol identifier and VLAN identifier fields are looked at more frequently. Although VLAN identifiers are assigned to frames, the switch does not do so randomly. Some of the factors determining the selected VLAN ID to be used in VLAN tags will be discussed in the next video. Thank you for watching.